How does a curveball curve? Baseball isn't just about throwing and hitting a ball, it actually has a lot of physics in it. Take the curveball, for example. Many people years ago had believed that it was just an optical illusion, or that it was easier to throw than a fastball because you throw it with less force. However, both these misconceptions are wrong. Curveballs do indeed curve, or break, over the plate. A curveball is a pitch that appears to be moving straight towards home plate, but is actually moving down and to the right or left by several inches. A ball that spins 30 times a second can break as much as 17 inches, which takes less than half a second to reach the plate. But how is this possible? Well, there are two basic factors that create a curveball: the proper grip and air resistance. Properly holding the ball is an important factor to make it curve. You have to use two fingers and a thumb, holding the baseball between them, with the middle finger resting on the seam, which is the red fabric of the baseball. Then, when you release the ball, you have to snap your wrist, causing your hand to be facing towards the plate and forming topspin on the ball. The ball will break down and away from a right-handed batter if it is thrown by a right-handed pitcher. The spinning action created when the pitcher releases the ball is the secret behind the curveball. This spinning causes air to flow differently over the top of the ball than it does under the ball. The top of the ball is spinning directly into the air, and the bottom of the ball is spinning with the airflow. The air under the ball is flowing faster than the air on top of the ball, which creates less pressure and forces the ball to move down or curve. This imbalance of force is called the Magnus effect, named for physicist Gustav Magnus, who discovered this in 1852, that a spinning object traveling through a liquid is forced to move sideways. Adding to the air pressure exerted on the ball are 108 red stitches that hold the cover on the ball. Because they are raised, the stitches increase the amount of friction created as the air passes around the ball and places more air pressure on top of the ball. If you've ever seen a batter jump out of the way of a baseball that ends up crossing over the plate, you've seen a good curveball. However, when a pitcher throws a curveball, do you have to throw it slower than you would a fastball? This is a mistake many young pitchers make when throwing curveballs. As the Magnus effect implies, the faster the ball is traveling, the more spin and therefore more curve it would have. So actually, if you want the ball to curve, the velocity you throw it at is very important. Here's a fun fact. Density affects how far the ball will curve because it affects the amount of drag a ball will have. In higher elevated places, the density of the air is more, so there is more drag created and therefore the ball can curve more because the air molecules are causing more resistance to the ball. Whereas in lower elevated places, the density is less, so there's less drag. Of course, in order for the ball to curve significantly different, the elevation of the two different places must be very different as well. So, to sum it up, unequal pressure on both sides of the ball caused by air resistance is the reason for a curveball's curve and is not a mere trick of the eye.